So this set of notes is on differential equations. I'm going to show you how it works with just regular derivatives. Differential equation essentially is your derivative is equal to some function, and what's implied is we're going to find the antiderivative function. Okay, and so essentially a differential equation is integration, but I'll show you how it works. I'm just going to break it down a little bit. So we kind of were doing this without really explicitly doing this, but essentially with the differential equation, what we're going to do is we're going to split up the dy and dx. Okay, so we move the dx to this side, so we multiply both sides by dx. And I say, essentially what this statement says is a change in y is equal to the height of the derivative graph times the change in x, or the width. And then we solve for the y by integrating or summing up both sides of the equation. So the sum of all the dy's is y. The sum is all the e to the x dx is this sum here. Okay. So essentially what we've done is we've actually split the dx to this side with the x expressions, and we integrated both sides of the equation. Okay, so that's kind of what we've actually already been doing, but now we're going to formalize it a bit more because we're going to do this in the context of something called a differential equation. So let's take a look at this problem here. We have a function y has a horizontal tangent at x equals -1/2, okay, and x equals 0. So we have basically a min or max at those points. It has a coordinate at 0, 12, which means the y-intercept at 12. It also has the second derivative. This is a differential equation for the second derivative equal to 4x plus 1. We want to determine the function y. Well, essentially we're being asked to anti-differentiate twice. Okay, so it kind of looks like this: d squared y over dx squared equal to 4x plus 1. I'm going to say the second change of y is equal to 4x plus 1 times dx. I'm going to integrate both sides. Okay, so I end up with the first derivative is equal to the antiderivative of this. So we end up with 2x squared plus x plus c. So that is the f prime, or the y prime. And so we need to, what's implied is we need to solve for c. Well, we can solve for c by looking at these two terms here. When x is 0, I know that the slope is 0, or this expression is 0. And we also know that when x is equal to -1/2, we also know that's the same. So I'm just going to plug in x is 0. So y prime when x is 0 is equal to 0. And so I put in 2 times 0 squared plus 0 plus c. C is equal to 0. Okay, so we end up with c is equal to 0. So my y prime, which is the same as dy by dx, is equal to 2x squared plus x plus 0. Okay, so I'm going to do the same thing, but I'm going to, again, I want to split up the dy and dx. I'm going to say the change in y is equal to the derivative function times dx, and then integrate both sides. So I get y is equal to, that's going to be 2x cubed over 3 plus x squared over 2 plus c. And then we can solve for the c using this term here. We can plug it in, x is 0, but we can see that the c is going to be the y-intercept in this case. So I'm just going to call that c1, call that c2. So then the equation becomes y equals 2x cubed over 3 plus x squared over 2 plus the y-intercept of 12. Okay. So here's another differential equation. It says that the derivative changes in proportion to the population. Okay, so this is what the population grows proportionally to its size and is governed by a differential equation. So this differential equation, the rate of change is proportional to p, so it's k times p. A particular population grows at 5% per year. Using antiderivative, determine the population function if the initial population starts at 1,000. Okay, so I need to find the p value. Okay, so I need to solve for p. So I'm going to separate this out. So I'm going to say that dp is equal to kp dt. Okay, and the antiderivative, I'm going to integrate both sides. So I'm going to have p is equal to k times p dt. Okay, so what function, when we anti-differentiate, is itself? Well, that's got to be the e function. Okay, so we're going to have p of t is equal to k e to the t plus c. So we need to solve for k. Well, in this case, k is my